Good evening to all respected resource persons, participants, and colleagues. It gives me a great pleasure to welcome you all to our day of Academic Development Program, Master AI Applications from Classrooms to Boardrooms. As we move forward in our journey of learning, let us keep this thought in mind. AI is not about man versus machine, it is about man with machine. This simple yet powerful idea reminds us that artificial intelligence is not here to replace us, but to empower us. The true strength of AI lies in collaboration, combining human intelligence with machine intelligence to achieve more than either could alone. Through today's session, we will continue to explore how AI can become our partner in teaching, research, and professional practices, helping us carry insights from classrooms all the way to boardrooms. So it is my honor to introduce our esteemed resource person for the day, Dr. Bhartendra Rai, Professor of Business Analytics in Chartered College of Business at University of Massachusetts, Dartmouth. Dr. Rai is an accomplished academician and researcher with expertise spanning applied deep learning, big data analytics, data mining, decision techniques, and operations management. His research interests lie in machine learning and deep learning applications, and his widely followed YouTube channel on deep learning featuring Keras and TensorFlow tutorials is assessed in over 225 countries worldwide. Dr. Rai holds a PhD in Industrial Engineering from Wayne State University, Detroit, along with 2 master's degrees specializing in quality, reliability, and operations research from Indian Statistical Institute. With more than 20 years of consulting and teaching experience, he has worked across industries, including automotive, electronics, food, chemical, software, and defense. His professional journey also includes over 5 years at Ford Motor Company, focusing on analytics, quality, and Six Sigma. His contribution to research are published in reputed journals such as IEEE Transactions on Reliability, Reliability Engineering and System Safety, and Quality Engineering, among others. He has delivered keynote talks at international conferences and earned recognition such as Employee Award by FAIA for his PhD dissertation in support of Ford. He is also a certified ISO 9000 and ISO 14000 lead assessor and a Six Sigma black belt from ASQ. We wholeheartedly welcome you, sir. Sir, you can now start your session.
Thank you, Dr. Arora, for the introduction. So, welcome everyone. I see we have, I think, more than 50 participants.
It will go up to 100 also.
Oh, okay. So my presentation is about artificial intelligence in supply chain management and operations optimization. My name is Bharatendra Rai, and I'm from Chartered College of Business, UMass, University of Massachusetts, Dartmouth. So this is like about one hour by car from Boston, so not very far away from Boston. I have been actually working at this college since 2006, about 20 years now. It has been a very interesting journey. This is my PhD student who graduated in 2022, doing PhD in Industrial Engineering, and her thesis was basically more focused on AI and machine learning and related applications. The outline of today's session will be combination of the two, AI and supply chain. We'll start with the very basic understanding of supply chain. I'm sure everybody is aware of that and has good knowledge about it. I'll also talk about AI. This will not be like a one-way kind of talk, but it will be more of an interactive session where more than 50% of the time you are expected to work with me on some hands-on activities. I'll get started with supply chain. So this is a very typical flow chart that I'm sure you may have seen. It starts with the supplier, like if you go from left to right, and ends with customer. But when we talk about supply chain, actually what activates a supply chain is the customer. So a supply chain always starts with the customer, although we see that towards the end. And all stages, whether it is a supplier or manufacturer or distributor, retailer or customer, so all the previous stages are basically involved in fulfilling a customer request. So for example, if I want to buy a camera and I go to Amazon and look for some options, and then I decide to buy a camera for $500. So that $500 is the revenue that Amazon will get, but then it gets distributed across the entire supply chain in certain way. A lot of information is involved. There's a flow of information, flow of products, flow of funds throughout the supply chain. The main objective of any supply chain management, when management comes into picture, is to maximize supply chain surplus, which is the difference between customer value and supply chain cost. So customer value is that money that comes as a revenue, like the camera that I mentioned, $500. Customer pays $500, and because a customer values that camera at that 500, or maybe expects that they are going to extract more value, so they are ready to pay $500. But then to fulfill that customer need or want, so many actors are involved in the supply chain. So there's a transportation, there's a retailer who is like keeping it somewhere till it gets sold. Somebody is manufacturing it. So all those cost money. And as long as the customer value is greater than the supply chain cost, a business or a company is profitable. There are a lot of examples you may have already come across. I will just list a few here. Like Walmart is a very interesting name. Anybody who teaches supply chain management, I'm sure when you teach supply chain management, you give examples similar to some of these. And Walmart is known for a very, very efficient supply chain. From $1 billion in 1980, they have grown to more than $600 billion in 2024. You can see this simulation where the distributors are growing from one place and then it spreads out all across US. And while watching this, you may notice a pattern that when there is a dot at a new place, there are dots surrounding it. So basically the idea behind that is like Walmart should be able to replenish their products or items with minimum cost. And they can significantly reduce transportation costs when the distributors or the people who are filling the shelves are close by. And that's something most of the people do. Like if you look at big automotive companies, let's say in Pune, India, you have Tata or Bajaj. So their suppliers are actually located very close to them. I remember in my consulting days in India, where I worked with like hundreds of companies, many suppliers to automotive companies, like there was a Ponce Autocomp, and they were located like you can stand there and see Tata very close, because if you are very far, then transportation cost goes up significantly. 7-Eleven is another example, Japanese company, and they went from 1 billion yen to 12 trillion in 2024, from 74 to 24, you can see. And they are also very effective when it comes to minimizing the supply chain cost. That second number in that equation, customer surplus minus the cost. So they are also very well known for minimizing that cost. On the other hand, there are so many examples where a company did not manage supply chain well. And Webvan, for example, they had excellent idea of delivering fruits and vegetables actually, or groceries to individual houses from big warehouses, but they were not able to manage the cost, transportation costs and other costs efficiently, and they folded or went bankrupt within 2 years. Borders was a very well-known company in 2004, and they had to close everything after they failed to compete with the efficiency of supply chain of Amazon. So supply chain plays a very important role, like how you manage, how you minimize the cost, basically the second component of the supply chain. So that becomes very critical. This slide basically relates that to the importance of decisions that are made at various stages. So if you look at this triangle, there are some decisions that are made at maybe supervisor or lower management level. And those are like day-to-day decisions. Like if a company has like 24 machines, who will work on which machine, what kind of products will be made. So there are lots of decisions. So that's why the area is bigger. But as you go up, like design-related supply chain decisions, although maybe less in number, but they can have huge impact in terms of cost. So decisions that are made here, typically like those people are involved, like senior management, and the impact could go on for several years. I remember I worked with a consulting company in US, and so basically they were working with the big European company who had their barges full of wine bottles coming to US at New York port, and they had one warehouse located on the west coast in California. And to reduce their transportation cost, they were planning to have one more warehouse. And location, basically, they were trying to figure out like whether they should do that in Chicago or like somewhere south, Florida or Michigan, something like that. Once that warehouse is opened, so it's not that you can just, if things go wrong, you can just cancel the project and move to some other location. So it is a very time consuming, and a lot of money is already invested. So that can have a huge impact for many, many years. So there are two popular views of supply chains. One is cycle view, where things start at one level and then there's a cycle, like there is a supplier and customer relationship. So I go on Amazon and I want to purchase a $500 camera. So the cycle between me and Amazon, so that is one cycle. So Amazon is the supplier, I am the customer. Then there's another cycle, which is where Amazon is the customer and they are getting the camera from a manufacturer or a warehouse, whoever it is. So there's a cycle like that. So that is one view. And other view is the popular push and pull view, where pull is execution is initiated in response to a customer order. So everything starts happening once there's a customer order. So that is pull. And push is execution is initiated in anticipation of customer orders. You figure out like what the customer is going to buy and how much, and then you start making them. The key questions that comes to mind when we are talking about supply chain management are some questions like these. So where should the plants be located? So this is Toyota. And what degree of flexibility should be built into each? What capacity should each plant have? Should plants be able to produce for all markets or for some specific contingency markets? How should markets be allocated to plants, and how frequently should this allocation be revised? How should the investment in flexibility be valued? All very relevant but very supply chain related questions, and then those actions have huge impact on supply chain cost. Now switching gears, let's briefly talk about artificial intelligence. So I remember watching a video like some time back, YouTube video, where Steve Jobs, who started this company called Apple, he was giving an interview in I think 80s or 90s, so very old interview. And he was giving an analogy where he was talking about a study reported in literature where somebody studied locomotion, basically, like how much energy or with how much efficiency various animals or species move from location A to location B. So there are a lot of animals, like for example, horse can move from one place to other place very quickly. Maybe elephants may not. So in that list of efficiency, humans were way down. And then somebody repeated that study with a human on a bicycle. So bicycle is a tool. And with that, the humans came at the top. So they left everybody behind in efficiency. So he called the computer at that time basically bicycle of the mind. So he used that study and called computers that computers are bicycle of the mind. So he was talking about computers in 1990. So this is Apple, and it had a RAM of 1 megabyte and storage of 40 megabytes. So that was like, at that time, it was unheard of technology. So much space, you can store like almost everything. So that was 1990. But today, things are different. If you compare, this is a IBM supercomputer, mainframe computer from 1960. And there are two scientists who are operating this computer. And in 2025, even our smartphones are much, much more powerful than those computers. So technology has come a long way, and that has allowed a lot of things to be implemented for improving productivity. And obviously, like from time to time, anytime something new comes, people try to challenge it or find faults or try to say that there are a lot of dangers involved. So that reminds me, like I read somewhere, I think it was Plato, who is a great thinker. So he mentioned at some point that Socrates, another great thinker, was worried that writing will make people's memory bad. Like people will not remember things if the technology like writing becomes like common. So that was a time like even writing, they thought that it can spoil people. And I remember in US there was a time when calculators were banned in schools because it will spoil kids. Kids will not learn like properly how to add, multiply. So calculators were banned. But everybody knows that like when you are using a calculator, chances of making a mistake is removed. So AI is, I think, at that stage where people are talking about it in so many different ways. Some are positive, some negatively, some are scared that it will lead to all kinds of things. Even like anytime new technology comes, one major problem people talk about is people will lose jobs. This is actually from last week. I think China conducted this robot Olympics where all these robots are competing in 400-meter race or 400-meter relay and things like that. So there were 280 teams from 16 different countries that participated in these Olympics where robots were competing with each other. So these are all terms that I'm sure you have heard of. Artificial intelligence is a like bigger umbrella, and then within that you have like subsets. When I look at artificial intelligence, I look at it as a basically productivity improvement tool. So you can use artificial intelligence to do things faster. If I have to, let's say I'm writing a paper, research paper, and coming out with the first draft takes a lot of time. And if I can use some kind of AI that can speed up things, so I can be more productive. So that's the idea behind artificial intelligence, where people are coming out with technologies that can make people save a lot of time. We have driving cars now, not just Tesla, but you have Waymo through Google, and you sit in the car and the car drives itself. So just this weekend, we went to Vermont, and it's almost like 300-mile journey. It takes 5 hours. And the good thing is that because the car is driving itself, you don't feel tired. You are just sitting there, you're listening to an audiobook or talking to somebody on phone, but you don't feel tired because you're not constantly driving the car. It improves my productivity in a way, and also like cars have become smarter. Like sometimes it will say that because you are driving 300 miles and you have only like less than 300 mile of battery left, so this is the place you have to charge. And while driving, it figures out that actually because of maybe downhill or whatever, it gains some, and it will change the map automatically saying that you don't really need the charging because you have enough charge. So those kind of things also make it smart. It gives them some kind of ability to make decisions for you. Obviously, you can always rule over them and say, no, I don't want this. I just want to keep the way it is. So artificial intelligence has been implemented in so many different ways, using so many different tools. Machine learning is one. You must have heard of methods like extreme gradient boosting. Anybody uses Kaggle? Kaggle. Kaggle is a repository of data sets. So some people are mentioning they are aware of it. I encourage actually my students to go on Kaggle and participate in those competitions. One, to gain experience with the real world data. And if they get interest and if they land in top 10% of the Kaggle leadership board, so there will be so many companies that will be after somebody who is like in top 10% of Kaggle, because these people have rare skills, and those skills are very, very much needed by many companies who are trying to implement artificial intelligence in their companies. So one thing I have noticed on Kaggle is people who have won competitions and shared like what they did. So typically, if it is a classification problem with the data or a prediction problem with the data, one of the machine learning methods, a popular machine learning method they use is extreme gradient boosting. So that is one of the most popular among the top Kagglers, you can say. Similarly, if it is related to some kind of pictures, videos, working with them, then typically CNN, convolutional neural networks, that's like very popular, like a gold standard for coming out with a good model. CNN is more of an example of a deep learning where we use neural networks where you have not just few layers but hundreds of layers. In fact, large language models, mostly you'll find that they implement artificial intelligence ideas using neural networks where they are working with the billions and billions of parameters. And those billions of parameters, training those kind of models is not easy. Like, we may not have resources to do that. So these things have become very popular nowadays. If you go on Google Trends, that tracks what people search on Google and how popular a term is, you'll find that large language models, which is the blue one, has taken off significantly since somewhere here, which is later part of 2023. And right now, it is at a very high level. So 100 equates with the highest possible searches at that time on Google. This is a dashboard, and you can see like China is doing very well. Like, most of the things are happening there. And no wonder that that robot Olympics that happened last week was also held by them. So actually, I would say China is currently leading when it comes to AI in the world. The kind of things they are doing, I think everybody is trying to play catch up. When you search for these AI related tools, some of the most popular ones that comes to the top is ChatGPT, obviously very popular, and GPT, LangChain, OpenAI, and Hugging Face. So if you are in the field of AI or interested in AI, I will definitely encourage you to go to huggingface.com, open an account, and see kind of platform it is. Actually, it is very interesting. Lots of data sets, lots of realistic data sets, and not only that, there are already a lot of working models that people share there. For some applications, you don't have to start from scratch. You can start from where somebody has already completed, because they share everything. It's open source. You have the codes, so you can start where somebody has already taken something and build it higher. So that's a very interesting platform for AI applications or anybody who is like interested in AI. If you only like focus on LLM, large language models, and why I'm saying only LLM, because anything, any process or anything that you want to optimize can be converted into language. Like, you can convert that into a written thing and then try to optimize that. So it has grown actually. Just content creation market has grown from 24 to 25, from 2.5 to 3.5 billion, and by 2034 it is expected to reach about 75 billion. So this is just one component of the previous applications that I mentioned. Now, training these models obviously is not easy. Like GPT-3 by OpenAI, it had about 175 billion parameters, and they used approximately 10,000 GPUs. GPT-4, 1.76 trillion, and you're talking about 25,000 to 30,000 NVIDIA GPUs. You look at anything here like Grok, for example, by Elon Musk's company X, they use 16,000 GPUs. No wonder a company like NVIDIA is a now $4 trillion company. And there are not many countries in the world even close to the market cap that NVIDIA has. So that was a very quick introduction to supply chain and AI, and trying to connect the two. Will make use of hands-on activity. If I have to actually make a summary of what efficient supply chain management is, so that summary is that if you can make supply equal to demand, then you have the best supply chain in the world. So all the planning that any company does is basically based on the demand forecasting. So when I was working at Ford Motor Company, and we know that next year we may need 250,000 cars, so that many engines. So all the planning starts from there. So for that, how many people you need in the shop floors? So how many machines you need? Do you need extra machines, or you have to lay off people? Things like that. So everything starts with demand forecasting, and I'll be surprised if there's any business that doesn't use some kind of demand forecasting. So we'll start with this. So POSIT, POSIT, and cloud. So once you hit enter, it takes you to this website. So I'm just clicking on the first one. It's called POSIT Cloud, and it gives you a lot of information, but you can click on get started. Let's see what we get. So it gives you a lot of options like free and the basic, standard, so on. We'll go with the free one. For this session, free is good enough. In fact, like, I ask students throughout the semester to use free, and they're able to use it. So it's good enough. And then if you are doing or using it for the first time, it will ask you to sign up. What I do is I just use my Google account. Now, when you come in, you may not see anything under your content because you may be using it for the first time. I've been using for a lot of time, so I have a lot of projects here. On the right side, top right side, you see new project. When you click on that, you see this drop down thing, new RStudio project. So it says R version 4.5.1. So that is the latest one, 2025 June 13th. The reason I'm using this cloud version is because it works for everybody. Whether you are using Windows or Mac, it's not a problem, it's free. What I will do is I'll go to Tools, Global Options, and Appearance, Editor Font Size. Let me increase this so that it is easily visible on your screen. Apply, OK. So now you get a bigger font size. And to create more room, I'll just cross this out where it says Posit Cloud so that we have more room, and then File. So when you go to New File, you'll notice that it has a lot of different options. First one is R script, but it can do actually much more. You can create apps like what people do on Shiny web app. You can use it for C++, HTML, Python, SQL. So it's a multi-purpose platform. Earlier it was called RStudio Cloud, and then they changed the name to Posit Cloud because now it includes a lot of different options. So I'll go with the first one. When you are here, you'll see that this file is named as untitled1. I'm going to rename this. We can say save as, let's say demand, because we are going to do time series with demand data. So as soon as you say save, two things happen. This file is now called demand.r, and that appears in the fourth window. This demand.r is available in the fourth window. Now from here on, whatever we do on this page, due to some reason you lose internet, due to some reason there is a power outage. So whatever you have done, you're not going to lose. It will still be stored in the cloud. Using a hash symbol, we can give a comment, demand forecasting. So this is not a R code, it's simply a comment. And in R, there are a lot of free libraries or packages that we can use. I'm going to type some of them and then I'll show you how to use them. So there's a library called forecast. So this is for working with time, and time series always involves time. So you need this lubricate. Now one thing you'll notice is when I was typing these things, at the top I have some notification that forecast, lubricate and tidy was required and not installed. So now this is like AI speaking to you. It is noticing what you are trying to do and what you don't have. So it is asking you whether you want to install. So this is like a smart way of getting things done so that you don't miss out on something. So I will simply say install and let it install. So this is done now. Now to run these lines, now I can actually cross this out because I have these three. So you can select all three and then click on run button, and that will run and make these packages available. I need data. Let me copy and paste. Let me store the data in D, and I'm pointing an arrow towards D, which means whatever I'm going to put on the right side will be stored in D. So we are going to read dot, you can see dot CSV. So it's a CSV file, and file names, usually we should provide quotation mark. So 2 quotation marks, and then simply paste that link here. So whatever link that I copied, so that link you paste it. So now this D is there in the third window. If you click on D, it's a small data set from 2022 to 2025 July. So 3 years of data, and how many engines were sold each month. A company which is supplying these engines, they need to forecast the demand so that they can plan ahead, because it takes time to make or manufacture an engine. So this data is there now. Now the only thing is this data is not in a time series format. Like if you look at this, you have year, month and so on. So this is not a typical time series. So I need to do some data preparation first and modify a few things and then again store that in D. So I'm using a function called TS for time series. So it will identify the data as time series data. And if you look again in this data set, the last column, engines sold, E capital, S capital and underscore in between. So the way I can tell R where my data is D and then dollar sign. So after dollar sign, it will allow me to select any one of the three columns. So I'm selecting this one. So that's our engine data. And then I have to say what is the start date for this time series and what is the end date, or it will automatically pick up. So using C and brackets, I can say we start in 2022. So 2022 August. August is 8th month. So I can say 2022 8. So that is the starting point. And what kind of data this is? So frequency, it is a monthly data. So frequency is 12. Now, as soon as I do that, you will notice in the third window now D becomes time series data. And if you want to plot how it looks, this is how it looks like. Now, usually when we do time series, there are like many courses available, and it is very time consuming process to arrive at a good model. But that's where AI helps. So as I mentioned earlier, AI tools help to improve productivity, or like make you more productive. You can do more in less time. So I'm going to create a model and store that in model and put an arrow. And the function that I will use in R is called auto arima. So I'm going to automate the process, let it figure out all various aspects of the time series. What I'm interested in is getting a final good model. So I simply provide D and run, and in no time it runs everything. It looks for various different types of models and stops. So everything is now stored in the model. If you want to look at summary of the model, you can get all that information available to you. So it says, for example, it is a ARIMA model, and it gives you all these parameters. The format is this PDQ is basically non-seasonal component that doesn't depend on seasonality, and uppercase PDQ is the seasonal component. Things happen as per the season, like ice creams get sold more in summer season. So for P, you see a number called 0. So that is the auto recursive order, and the order is 0. When you see 1 for D, so that is a integrated order or differentiating degree, and that degree is 1. So time series data has been differentiated or differenced once to achieve stationarity, because you need stational time series parameters. And then you have a moving average related to Q, and 1 means moving average of order 1. So it is only looking at the previous month for the moving average. And then similarly for seasonality, you have P for seasonal autoregressive order, because even in the picture you cannot see seasonality. It's more of a flat picture. So seasonality is not there. That's why P is missing. D, which is seasonal differencing, that is missing. And Q, which is moving average, that is also missing. So we don't need those parameters. And then you have seasonal periodicity, which is also not mentioned. Typically, if it is a yearly data, and if you have seasonality, it will be 12. So you get all the coefficients. You also get this AIC, which measures how good or bad the model is. So we were able to do that very quickly only because we made use of a tool. Now, what many companies can do is build some kind of app around this, where you get the demand data and then feed that into your economic order quantity, like what should be my economic order quantity be for this kind of situation. Let me ask you a question. So when we use this auto_arima function in R for building the kind of model we just now built, what do you think was the primary purpose of auto.arima function? Anybody wants to answer that? So somebody is saying D, somebody is saying B. So looks like competition is between B and D. Okay, so let's narrow down on B. B is to automatically select best ARIMA model based on criteria like AIC, and D was to calculate inventory levels directly from time series data. I would say, I think those of you who replied B is the correct, because so far we didn't talk about inventory. We only talked about how it reports AIC and picks the best model and reports various parameters. Now let's do the inventory optimization. One is I want to basically arrive at economic order quantity. If in operations, that's a very important activity. So you have the entire supply chain, you figure out like what is the demand likely to be, and you want to figure out how to optimize your order quantity. Now, before I move, let me also use the model to do some forecasts. So I will store forecast in F, and to forecast for next 12 months, we can say that I want to use the model. So the model which is stored in this model, and the horizon, prediction horizon is 12. I want to predict for next 12 months. So you run that. Let me see if I can auto plot using F. So it gives you a prediction with some confidence bands. Let's say our demand forecast for the next month, first month. So that value is given here. It is available in F. So I'm going to use F where the forecast values are sitting, and then choose a dollar sign, and then use mean and specify that I'm looking at only the first observation using a square bracket. So you run that. If you only select D1 and run, it tells you the value. So this exact value is about 1394. So basically 1395 engines will be needed in the next month. So that is the demand for the next month. And let's say ordering cost, OC, is $2,500. So each engines are expensive. Ordering cost is $2,500. Run that. So that gets stored in OC. Another cost, important cost, is holding cost. If you have to keep the engines before they are assembled in the car and sold for a long time, then there is a price to be paid. Now suppose that cost is $110. So cost per engine per period or per month, because you need a space, you need to like transport from one place to maybe a storeroom or whatever. So that is the cost. And then let's say LT, lead time, is 2 months. So when you order something, it takes 2 months for that engine supplier to really give you that order. So with all that, we also need a variability, demand underscore standard deviation. So SD, let me see if this works or, okay. So standard deviation is about $108.94. So with this, I can calculate EOQ. I'm just using the standard formula, square root of 2 times the demand forecast, which is in D1, times the ordering cost, OC, and that divided by holding cost, HC. So it will report EOQ, or economic order quantity, will be 251, which is minimizing the ordering cost and holding cost. If you want to calculate safety stock, how much to keep so that you're not having a stock out situation. So safety stock, we use a standard normal distribution 1.96 times the demand SD, the standard deviation for demand. As I start typing, actually it pops up, so I select it, and then square root of lead time. So these are standard formulas. So that gives you a safety stock. To avoid stock out situation, you need to keep about 301 every month. Typically, like what people do is they go to one tool for doing one thing, another tool for doing another thing. Now, how AI comes into picture, you can automate that process because we have limited time. But the idea is the next step will be, if you are working as a student in a company and you are asked to create an AI for inventory optimization, you use the auto ARIMA function and make the prediction for next 12 months. And then in the Shiny app, also create these simple formulas, which takes like 5 minutes to simply type, and create some kind of app around it where somebody just clicks a button or presses somewhere, and immediately they get a number. It's very useful to learn some of the skills for implementing AI in practice. Two leading tools are R and Python. So nowadays, like most of my classes that I teach, even to undergrads, I make sure that they have some knowledge about coding. And good thing about R is that you see, like ARIMA models, it's a very, very complex topic, but a very small function, auto.arima, and then suddenly you have the best model. So learning these codes is almost like given for anybody. You need to learn basics of cloud computing. You need to learn basics of SQL, structured query language, because all these huge data sets are sitting, and then somebody has to extract that information from these data warehouses. You need that standard language. And statistical methods always, they are the foundation of anything that you do with data. Anybody like who wants to get started or already like has made some progress, I do have some lectures on some of these machine learning methods. I also have a lecture on how to create an app that you can use for implementing any AI in practice. With that, I would stop. If you like, I can also pose one more question. I'm putting that in the chat. Let's see. Some people have started answering. B. I think B is the correct answer. Standard deviation of demand during lead time, because safety stock is calculated using standard normal distribution, and we use sigma and square root of lead time, where sigma is the standard deviation of the demand, reflecting variability during the lead times. Because lead times are not like, if we say 2 months, sometimes it can be delayed because of so many reasons, as you know, like risk in the supply chain. That's the benefit of like working with the many of the faculty members, that they are sometimes always paying attention, and I think you have been teaching, maybe teaching for many years, so it is already in your mind. So in this session, basically we try to start with the big picture of demand, and then how that gets used, that information, in the supply chain for making day-to-day decisions. And when you basically create some kind of productivity tool using R or Python, where these things can be simplified and can be done in less time, where people save time and less chances of error. Like if somebody is doing with calculator or by hand, sometimes there may be errors, there may be typo. So all that can be avoided using AI tools.
Dr. Rai, this is Dr. Savita Desai from ST College. So I think we had a discussion with you that you are going to make the session very much interactive, and really from good of my heart I feel that you have did your wonderful job. I sincerely commend you on behalf of AICTE and SD College for giving experiential learning opportunity to all the participants. I think this is very much indicative that I like to hashtag you with the supply chain manager, that how you had made this session so much interactive. And it is really reflecting that yours exceptional expertise, how you have given the learning experience to all the participants. We are highly obliged, and thank you so much for such a wonderful session.
Thanks, Dr. Gupta, for inviting me and this opportunity. And it's always like good to work with you. We have worked in the past, and I think I always enjoy it. And I know like these the topics that we cover, especially AI. I think I found this very interesting, because nowadays everybody is talking about it, and even our students, when they go out, people expect them to have some project done and things like that. So I thought I will combine the two concept and little bit of hands-on with R, so that it can go to students finally, who can make use of it and show their abilities when they go for job interviews. I hope like this was helpful in some way, and I'll be happy to be in touch again.
So wonderful to see all the beautiful and smiling faces, and very much AI creators.
In fact, personally, I have seen many of the videos of Sir and have really learned a lot of things like indecision analytics and R. Sir, I don't use Python, I use R only.
Yeah, I was talking to ma'am on a day before yesterday. I had a code to make India's map and all I have did, so it was not happening. So she said that I'm very much comfortable on R, not on Python. Own excellence in resolving all the issues and technical problems. Tools are too good to have both. So there are the participants from 20 states.
Oh, wow.
And highest number is from Tamil Nadu, followed by Punjab and Bangalore.
I wish you good luck. So thanks very much for this opportunity, and I wish you good luck. Hope to see you again.
Thank you so much, sir.
Thank you.
Thank you for such a wonderful practical session also. Thank you, sir.
Thanks. Bye-bye.
Thank you so much.